All right, we're going to talk a little bit about, take a look at some problems from the book that you guys can finish up for me. But the properties that we've learned about limits so far, both in Calc 1 and in Calc 2 so far, are going to help you talk a little bit more about the idea that whether or not a series converges. Now, we have to be careful. A series is a sum of values, and it can converge to a single sum, single value, versus these divergent and convergent functions that we've been dealing with so far. They're different things. Divergent and convergent functions are interesting. You graph them and you're deciding if we've been dealing with area underneath. Is that area underneath convergent, a singular value? Well, we can also look at sequences and decide, whether or not that summation of values, which actually is kind of like area under a curve, and in fact converges to a value as well. So we'll try and help out as much as I can on clarifying the difference between the two. But here, what we're going to do is go to the page 485 from your 10-1 textbook, and there's some review at the front. Important stuff kind of pulls together what we know. The idea is there's these a sub n functions. They can be anything. And what it is, they're functions with n in them. And we use that term a lot. So I'm going to keep a sub n as describing any type of function that we might put into a sequence. Now, if we do the limit on this thing, we already talked about some properties. We know what this limit is, right? We get 0. There's a denominator that has a higher degree than the numerator, so we know it goes to 0. It's bottom heavy. So, but what does this say about a sequence of that particular function? That's what becomes interesting. If I do a summation, a bunch of those, which, by the way, remember, is similar to taking the integral of. So if I go back and I take the integral of this function, remember, that's a summation of little areas of that function. So when I say the sequence and I do a little summation symbol in there, we are talking similar ideas, but slight variations on those. So let's continue on. So that one, we're going to ask, what did that last one say about the sequence itself? And then I'm going to do another one, number 9, and say, all right, we can do the limit on that. We know we get 2. All right, so there's more to the story. I got 0 for the first one, and I got 2 for the second one. That actually says a lot about those sequences. So here are the two rules that come up. Finding the limits of these a sub n functions is actually pretty easy. In fact, it should be your first instinct when you see a sequence with that summation notation, you have a function inside. Think of running the limit on the internal function first. Because if you can find out these two things, you can know a lot. If the sequence, if you do that limit on that a sub n inside there, what we just did a minute ago, if it's not equal to 0, that's like we had in number 9, the series diverges. That is, the sum of the terms you'd get from adding them all up diverges, interestingly enough. Okay, so as n goes to infinity, if we don't get 0, get some other value, the series diverges. That's different than saying the function kind of converges on a particular value. What we're saying is the series diverges. So series is just a little bit different. So let's separate those out. And again, if that's confusing, we'll spend a lot of time ironing that out. But then the rule then, some people might say, well, since the series diverges when the summation is not 0, well then when it's 0 it must converge. Well, actually, it could go both ways. We don't know for sure. So if it's not equal to 0, we know for sure it diverges. But if it's equal to 0, then we have to decide one way or the other with some other techniques. So that's the end of the story. Hope that gets you off to a good start. Here's your homework. I told you I'd give you one. I want you guys to tackle the 1 through, let's say, I'm sorry, what am I saying? 6 through 10. Would you guys tackle that on that assignment up there? I want you to go ahead and look at whether or not those sequences, where they go. Run the limits to infinity on those 3. And then we'll take a look at what those sequences look on that. So you're doing 6, 8, and 10. This is on page 485. The test is, if you do the limit to infinity on those, if it's equal to 0, the series itself, if you put a summation from 1 to infinity, then we'd say that series diverges. If it is equal to 0, then we'd say it goes, well, one way or the other. And that's something we got to work out as we go along.